Hi, we are Carlos Chapa, Anastasia Sandoval, and Adrián Varesi, and this is our key activity.
In this project, our team is going to recognize and then show the different types of functions that are shown in the everyday problem. These functions may come in different shapes, such as graphics, tables, symbols, or even in a verbal way. We will prove that the world phenomena can be translated into mathematical equations. While researching for the information, we found some websites with very interesting data. These websites showed us all how the world is always changing and moving.
Objectives. Throughout the project, there were three main objectives for us to learn in this activity. The first one was to recognize the real-world phenomena by mathematical functions. The second one, and a very important one, was to analyze the functions, their relations, and use tables, equations, or graphs. The last one was to translate the representation of functions, for example, graphing and verbal. If we had a graph, then we use the data and translate it into a verbal format.
Materials and method. Some of the materials we used were the links that the document provided us also. The links sent to us to different websites, Desmos for some types of the graphs and functions. Another material we used was Excel for the graphs. The method we used was based on the first X of all the charts and middle X, and the last X, and substitute the graph to understand how it's changing, and identify if it is increasing or decreasing. To generate the graphs, the team decided to use Excel and graph it here. We find all the functions in the main web page of the links.
Our team collaborated and analyzed each of the following graphics, and we discovered the domain, range of each function, and some other results. Here is the data table.
Symbolic function. Its dependent variable is the sector. Independent variable is the fossil emissions. The domain is power, and the range is the percentage.
Graphic function. In this graph, we can see the consumption of oil in all around the world. We can see the independent variable is the time, the domain is the years that have passed, and the range are the tons of coal the world consumes. You can see how it goes increasing, then stable, then at the end it increases again around 2012.
Here is the tabular function.
Graphic function. The dependent variable is coal consumption. The independent variable is time. The domain is the years that pass, and the range is tons.
Here is the data table.
Text. What information the function provides? The function is like a machine. It has an output and an input. The output has somehow a relation with the input, but a function doesn't really have belts or cogs or any moving parts, and it doesn't actually destroy what we put into it. Did the newspaper present the function in the best format? Well, yes. The newspaper was in the best format possible, and its interpretation was correct about the audience. How the value of the function depends on the independent variable. The value of the function depends on the independent value because if the independent value is in another point or place, it will drastically change. And that's why the function is always.
The team concluded that the world is increasing its quality of life in many aspects, but in turn, the world itself is more connected in all aspects, and now everyone is looking for a better quality of life. But considering everything that has happened in the world, knowing its history, Earth is improving, but knowing that the world has improved, but there are still parts of the world that the human right or the basic necessities of a human are not accomplished. And this is mistaken, because our team believe that if in other countries these rights are already achieved, why in other countries they aren't. And our team firmly recognizes that the world needs changes. We're not following conformism, but we have to recognize that Earth has improved, and this is not an excuse to keep improving the quality of life.